Okay, continuing our study of exponential functions, can you graph the exponential function f of x equals 3 to the x? So the way we can go about this, let's start making a table of some values. Okay, we know the domain of exponential functions is all real numbers, so I can plug in whatever I want, and using a calculator, notice that even if I plug in a pretty large negative number, my output is still positive. It's just very small, but it is positive. Because remember, 3 to the negative 10 means 1 over 3 to the 10th. 3 to the 10th is a very large number, so 1 over it is very small, but everything going on is positive. Plugging in other values of x gives me other values of y, and we can now start plotting these and trying to connect them. So if you have a piece of paper in front of you, I would go ahead and plot at least these ones in the braces, these intermediate 6 values here, 7 values. Plot those and see if you can connect them up with a curve. Okay, we do have a y-intercept of 1. Notice there's no x-intercept. 3 to the x cannot possibly be 0. I cannot raise 3 to any power and get out 0. Which does suggest some kind of horizontal asymptote. As x gets smaller and smaller, I have 3 to a big negative number. That's going to be the same as 1 over 3 to a big positive number, which is going to be pretty close to 0. Okay, but what about if x is getting big? Well, as x gets bigger and bigger, the output just gets bigger and bigger. It's going off to infinity, actually quite quickly. And here's what would happen if you plotted all of these on a graph and tried to connect them up. Notice, yes, on the left, as x goes to minus infinity, we have this horizontal asymptote of y equals 0. But as x goes to positive infinity, the function is just rapidly increasing up. This is not a vertical asymptote, though. The domain is all real numbers. It's going up quite steeply, but there is no value of x that you can't plug in. So this is not a vertical asymptote. So here are some properties of exponential functions, provided the base or the growth rate is bigger than 1. Okay? The domain is all real numbers, and the range is all positive numbers. The y-intercept is just 1. Notice this isn't c times a to the x. We're just doing a to the x without times c. The y-intercept is 1, and there's no x-intercept. You cannot get out a 0 from this function. You do have a horizontal asymptote as x goes to minus infinity. It is increasing, and it's 1 to 1. Let's go back to that picture on the previous slide so we can see it quite clearly. As I move from left to right, the curve just goes up and up and up. And remember, where a function is increasing, it's 1 to 1. Where is this increasing? Everywhere. It's always going up, which means it's 1 to 1 everywhere. Okay. Some common points. Here's your y-intercept that was already mentioned. If you plug in an exponent of 1, you just get a, but if you plug in an exponent of negative 1, you get 1 over a. These are handy points to always know belong to your exponential curve. And it's a nice, smooth, continuous curve. It doesn't have any jumps or anything. And here's your general picture. Okay, remember, this hasn't been multiplied by c. It doesn't have, its initial value is just 1. It's just multiplied by 1. So here's the intercept at 1. If I had an exponent of 1, I'd get out a, and a was bigger than 1. That was one of our assumptions here, so it went up. If I plugged in negative 1, I'd get out 1 over a, which would be smaller than 1. And notice, yes, we have a nice horizontal asymptote here. We are escaping to infinity in this direction, but it's not a vertical asymptote. Okay, there's no domain restrictions. The range is positive numbers. I'm getting out every positive number I want, but I can't possibly get out a negative number. And it's a nice, smooth curve. Okay, it's increasing, which means it's 1 to 1. Which means what? What do 1-to-1 functions have? Okay, that's coming later. So can you graph 1/3 to the x? This is very similar to the one we just did. We'll make a table of values. Okay, we did 3 to the x, and this is 1/3 to the x. And what you can notice is that 1/3 to the minus 1 is 3 to the first. 1/3 to the minus 2 is 3 to the 2. Also, 1/3 to the second is 3 to the minus 2. 1/3 to the first is 3 to the minus 1. You can compare these. That was my computer, not yours. You can compare these to the values from the previous chart we had and see that they're kind of flopped. I'm just going to skip ahead to the graph. Because we flopped all of our values, instead of getting out big values this way, we get out big values for negative x's. Sorry. And instead of small values for negative x's, we get out small values for positive x's. I still have a horizontal asymptote of y equals 0, but it's to the right. Now as x goes to minus infinity, y is going to infinity. And again, it's not a vertical asymptote. It's just going up very quickly. What we really did, if this was the curve for a being bigger than 1, we just have a mirror image of it this way, and this is the curve for a being less than 1. So a lot of the properties are the same. It's just the horizontal asymptote and the end behavior is switched in the two directions. It's not increasing, now it's decreasing. But otherwise, the domain is the same, the range is the same, the intercept is the same. Okay, so that's given in this chart here. The domain is all numbers, the range is still all positive numbers. There are still no x-intercepts, the y-intercept is still 1. The x-axis, or aka y equals 0, is still a horizontal asymptote, it's just in the positive x direction. And now I have a decreasing function that does mean it is 1 to 1, which does mean something special coming up later. And instead of containing the point, it still contains the same points, 1a, negative 1a, sorry, negative 1, 1 over a, and 0, 1. It's just now that since a is less than 1, 1 over a is going to be big, and since a is less than 1, a is going to be small. But it's still a nice, smooth, continuous curve. Here it is. It's just the mirror image of the a being bigger than 1 curve that we would have seen over here. Okay, so let's use some transformations, all of these horizontal, vertical, etc. shifts. Graph f of x equals 3 to the minus x plus 1. Determine domain, range, horizontal asymptotes, and intercepts. Well, you're going to want to start with 3 to the x. Okay, but 3 to the minus x represents this, this reflection across the y-axis. This looks very, very similar because 3 to the minus x is 3 to the minus 1 to the x, based on properties of exponents. My exponent is negative 1 times x, so I wouldn't say factor, but I can represent it like this. But 3 to the minus 1 is 1/3. So in fact, 3 to the minus x is the very same graph as 1/3 to the x. And there we see it as that reflection across the y-axis. And in this problem, we're almost done. We just need to now do a vertical shift by 1. If we shift this up by 1, the horizontal asymptote changes. Remember, we were asked, what's the domain, what's the range, what's the intercept, what's the horizontal asymptote? So what's the domain, what's the range, what's the horizontal asymptote, and what's the intercept? So the domain is still all real numbers, but the range is now everything bigger than 1. I took a curve whose range was everything bigger than 0, but then we shifted it all up by 1 unit. So now the range is everything bigger than 1. The horizontal asymptote also got shifted up to be y equals 1, and the intercept got shifted up to be 0, 2. Okay, so in the next video, we'll come back and discuss the number e, a very important number.